let's get started with the first problem of today. It's going to be LeetCode number 438, find all anagrams in a string. Given two strings s and p, return an array of all the start indices of p's anagrams in s. You may return the answer in any order. And an anagram, basically rearranging the words or the order of the letters in any way that you want. Okay? So I guess the first thing is thinking about, well, I think a pretty easy edge case is that if p dot length is less or is greater than s dot length, return false, or return empty list. And this is because if this is true, then there cannot be an anagram of p within s. That's just a pretty standard edge case, I think, because, well, we need all the letters within p to exist in some order in order for s for it to exist. And if s's length is less than p, then for sure it cannot hold all the letters within p. Similarly, if p dot length is equal to s dot length, we only need to check if this current letter is an anagram of p, or if the word starting at 0. And in that case, I'm starting to think of whether or not we want to do potentially a sliding window approach. And the reason why I say this is that realistically, what we want is to create a sliding window of size p.length and add all elements into a set. Of course, we'll also check to make sure that we'll also setify p, basically just adding all the, or mapify actually. We would make a map, a frequency map of both the sliding window currently as well as p. Then check to see if the maps are equivalent. Then slide the window forward, removing the element at the front, or decreasing the frequency by 1, and add the element in the back, or, well, actually decreasing the element at the back, adding the element in the front, assuming that the front of the sliding window is on the right side. And we just continue until the sliding window cannot move forward more. So, what will this take? Well, in terms of time complexity, we'll need to take O of p first in order to setify it. Then we'll take O of s divided by p for the number of, will it be s over p? Basically the number of string reads, or the number of reads within the string divided by p. I think this is reasonable, given that, let me think. Given that we create a sliding window, right? And we have to read in the values of the sliding window once. However, as we move along our S, as we move our sliding window along S, we are only adding one element and removing one element at the end. Thus, we aren't really doing much there. I think that's constant time work in that case. And so I think our overall runtime for this will be probably somewhere in the neighborhood of O of S over P, where S is the longer string usually and P is the smaller string. In terms of space complexity, we'll need O of P to store all the frequencies of P, and we'll also need O of S. At most we will have O of P-sized set, or a map. We'll have an O of P-sized map within the sliding window, because we always add an item and remove an item. So we shouldn't exceed, the number of items within that map should not exceed the number of elements within, or the size of P. So I think this is just still O of P, and this is whichever one dominates, should be O of S over P most of the time. I think this is my time and space complexity analysis. Let me think. Did we miss anything else? I think this is a good enough solution. Input set is 3 times 10 to the 4 maximum for both of them, which is pretty large, which makes this solution realistically possible. 3 times 10 to the 4 I think is a large enough or a small enough input upper limit that this seems to make sense. And I think a sliding window approach just works well here when dealing with contiguous subarrays. So I'm going to get started on coding, and then we'll see what happens. So first, let's deal with the edge case. So if p.length is greater than s.length, return empty list. It's just empty list, right? Not empty list of? Yeah, empty list. Then we can say var left is equal to 0, var right is equal to p.length. Well, before we do the sliding window part, let's setify or mapify. So val p frequency map is equal to mutable map of, this would be char int, p for each char, p frequency map dot get or put we either get the character or put a 0 in there with a lambda where this is the item, I think. So this is the get. Actually, do we want to do that? Because I think get or put is a little bit different. What does this lambda actually give us? Okay, so it either gets us the value or puts in a value. So actually, no. If p frequency, actually no, we can't do that. P frequency map dot put. We put into char p frequency map dot get or put char or 0 plus 1. Right, so by default we put in a 0 and then we add 1, or we get the current frequency and we add 1. Then we first start off by saying for index in left to right -1, and we need a S frequency map is a mutable map of also char int. So we had to start by populating the initial array, because we won't populate it like this in any other situation, in any other case other than the base case of our algorithm. Because in any other case, we will only be adding the first value and removing the front or the last value, basically. Starting by of sliding window. And then in this case, what we will do is that we will do S frequency map. Also, pretty much do the same thing. Put S get at index, and we will do S frequency map get or put S at index or 0 plus 1. And then what we would do is that we also need a return list is going to be a mutable list of integers, while right is less than s.length. So realistically, this should start at s.length -1. Let's see. If p is 0, 1, 2, so it has a length of 3, but 0, 1, 2. Okay, so yeah, we actually want to start it there so that if p.length is equal to s.length, then it will be equal to s.length -1. We will say if p frequency map dot equals s frequency map, then we do return list dot add left, which will be our actual index, and then we would do right plus, well, we want to add the next item, right? So if right plus 1 is less than s length, p frequency map dot put s at right plus 1, p, or not p frequency map, or s frequency map, s frequency map get or put s right plus 1, 0 plus 1. So if we have an element to the right that we can add, then we will add it. Otherwise, we won't. And then we can do right plus plus. And then we can do let's see, if s frequency map dot get s at left is equal to 0. Otherwise, we can do s frequency map put on s dot left s frequency map dot get at s dot left -1. Otherwise, we will just remove s dot left. I think for the mutable map, we can just straight up remove the key. But if we want to just, or if there is a value that is greater than 0, if yeah, so if it is greater than 0, so it's not null, and s frequency map get at s left is 0. This if not null check is technically not really needed because we do check against 0, but it's fine. But if it is not null and it is 0, then we remove it. Otherwise, we just decrement it. Though technically this could be 0. Or this could be null, rather. Due to the... Or at least according to compiler, that might be nullable. And in this case, if that is nullable, then we need to take care of that. Then we can just say if s frequency map get s left is not null, then we do that. And honestly, we could just do that to get rid of the null check on the top here, because we don't need that. But we do need it here, so we make sure that we don't get yelled at by the compiler. I think this works. So basically we slide the... We should also slide the left pointer. We can do it at the end. So move the sliding window forward. This is to remove or decrement the outgoing left side. Insert or increment incoming right side. Add the index to the list if we have a valid anagram. And I think this valid anagram check is pretty standard. Like it's pretty similar to what we've had before. I think this was the LeetCode easy to check if two lists or if two strings were an anagram. I think we did something very similar. We mapified both of them and then we checked if they were. We didn't use the equals check, and I'm not sure if the equals check will work. If the equals check does not work, then I will simply use the frequency map and basically check to see if all the elements within here are correct. Because it's a sliding window of the same length, we expect that the P frequency map should be pretty much exactly equal to the S frequency map. So let's see how it goes. Let's first run to make sure that we don't have any compiler errors, or check to see if we do have any compiler errors. Looks like it didn't really like it. Ooh, okay. This get or put, let's see. Mutable map. Get or put. Is get or put not valid? Oh, this needs to be wrapped within a lambda, I guess. Which is kind of weird. Though I guess maybe in some situations you'd want to use, you'd want to have a lambda there. Right, because this is a lambda with nothing that returns a value, so we'll just wrap it in there. And then smart cast to int here is impossible because you are a complex expression. So in that case, we'll say val previous value is equal to s frequency map get s left, and this should be of type int. And then we do previous value. So this should be force casted to int, and this should be valid because we already checked that it's not null. So we should be, the compiler should be smart enough to just straight up cast it in as to an int, but it's not. So we'll have to do that instead, and we can get rid of this declaration then. I'm guessing it doesn't really like that this is here. Looks like this equals is not working. So what we will do here is we'll do var is valid anagram is equal to false. And actually we can have if or p frequency map for each and this would be p entry if s frequency map get p entry dot key is equal to p entry dot value, or is not equal, then is valid anagram is false. And this will start off as true, and we can say if is valid anagram, then we can do return list add our left side. I think that might work better. Let's see. So we go through the frequency map for the for P, and then we just go through that. Looks like it's still not getting that. Let's see. Let's do a print line on the P entry. And let's do s frequency map get p entry dot key. So we have let's see. Oh, we don't want to do right -1. Okay, cool. So it looks like there was an issue here with our initial adding. Let's see if the dot equals part actually works. If the dot equals call works, then that would be goated, but doesn't look like it. Can we do a print line p frequency map? We'll do a like this. So index is equal to left. And then we'll do p is that, and then s is s frequency map, just so we can sort of see like what the frequency maps look like. So at there, let's see. Oh, this should be if is equal to 1, because it's on its way out, so we need to decrement it. Or we need to remove it, rather. Okay, cool. So it looks like the equals thing actually works. So let's go ahead and toss it through. So we'll just comment this like if the map frequencies are exactly the same, then we can return, or then we can add to list. And this, because we're running kind of a, like if we did it manually, we would have to check through each each item in P. This would run P time, or this would run in O of P time. Within this, which is O of S over P, which really means that this probably runs in O of S time then, because we're running through an O of P operation here. So I think it might be O of S time complexity rather than O of P or S over P or O of P, whichever one dominates, right? And it looks like this works. Looks like the runtime is pretty standard. Looks like the memory is all right as it is. And yeah, I guess I'm gonna leave it here then. This was a pretty straightforward solution, all things considered. And yeah, so I'm gonna leave it here. In any case, I hope you learned something, and I will see you for the next problem.